while I was in college. I had a company out in Los Angeles building satellites. A lot of people asked, what kind of education you have to have, how many years you have to go to school. Basically just a 4-year degree, and generally any kind of engineering. Back when I went to school, there wasn't really a specific aerospace engineering degree, but there are now, if you want to specialize in that kind of thing. Sorry, I'm not used to talking with a mask on. Let's see. So, satellite basically is anything that orbits something else, right? So the Earth itself is a satellite, because it's orbiting the sun. So, has anyone seen the pictures of like the space station, right? Where the astronauts are doing their spacewalks, and you can see the Earth is huge, right? Because it's really close to the Earth. So, the space station is actually only about 250 miles from the surface of the Earth. So, if this was the Earth, the space station is basically just like a half an inch from the Earth. It's really close. So most satellites, Mr. Carey told me you're talking about GPS satellites and GOES satellites. The GPS satellites are what's called like a mid-Earth orbit, and that's about 11,000 miles. So just to give you an idea of how far that is, if this is how big the Earth actually is, the GPS satellites are about this far away. And then the GOES satellites are about twice that. So we're talking about 3 Earths away, so about this far away. Now, the satellites are used for all kinds of different stuff. The very first satellites back in like the 1950s were launched mostly for scientific purposes. They wanted to use them to get a better map of the Earth. But now they're used for all kinds of stuff. They're used for weather satellites. If you ever watched the weather on the news report, all those images are coming from satellites. If you guys have DirecTV or Dish Network, anybody that has a car with a navigation system in it, or even your phone, right? Your phone has a GPS. The map function in your phone is using GPS satellites. And then just general communication. If you drive around and look at the roofs of like gas stations or grocery stores, a lot of them will have small satellite dishes. Anytime you swipe a credit card anywhere, it's sending a signal somewhere to get approval. So there's all kinds of things that satellite communication is used for. Okay, so the main parts of a satellite, I know you guys have talked about some of this. This thing's about 20 years old, so I'm going to try not to break it. You can see there's these big solar panels. They kind of look like wings, but satellite doesn't need wings to fly, right? You're in space, so there's no gravity, just sort of floats out there. But the wings are covered in solar panels, and that's how it gets its power. So the GOES satellites, for example, I mentioned it's like 22,000 miles away. And the reason that they're in this orbit is because when you're that far away, you orbit the Earth at the same rate that the Earth is rotating.
Anybody know that word? What that word is? It means that?
What that orbit is called?
Yeah. Geosynchronous orbit.
Okay. Because it's synchronized with the Earth. And the benefit of that, well, first of all, how long does it take the Earth to rotate once? Okay, it's 1 day, right? Because say Mr. Carey is the sun over there. So, and here we are in the United States. So this is noon, right? And then 12 hours later, it's midnight. And 12 hours later, it's noon again. I'm spinning it, I'm spinning the wrong way, sorry. So anyway, the Earth is rotating once per day, and the satellite is in this geosynchronous orbit so that it rotates the Earth once a day. And the benefit of that is that if we're here in Illinois looking up in the sky, that same satellite is going to be over us all day long. Okay? And so what companies can do is they can say, well, I want to provide service to North America, or I want to provide service to Asia, in which case they're in orbit over here, and they're tracking this part of the Earth. So that's what the geosatellites, the geosynchronous satellites are for. The GPS, like I said, is in a lower orbit. Maybe to stop.
No.
Okay. The GPS are in a lower orbit. They're actually circling the Earth twice per day. And those are usually it's like a train of satellites that are going around the Earth. And they sort of work together to provide a signal because they have to map the whole Earth, right? The idea is wherever you are, you want to be able to use your GPS receiver to figure out where you are.
How many satellites have to lock in to get your location?
Good question. I'm not actually sure.
I can't remember if it's 2 or 3.
Yeah, I was thinking it was 3, but
Yeah.
yeah, I'm not sure about that. Okay, a lot of people asked, how do they get up into orbit? So basically what you have to do is the company that buys the satellite also has to pay someone to launch the satellite for them. And they'll put it into a rocket. So if you see a rocket, it's a long tube with a lot of stages. At the very top there's a cone, and these satellites have to fold up to fit inside that cone. So for this one, for example, these panels will fold over. These long wings, which can actually be 3, 4, 5 panels long, just accordion up and fold up against the side so that they fit in this small space on top of the rocket. So this, the box, which is the main part of the satellite, it's basically the size of like maybe a minivan or a small bus. Okay, so it's not huge. And then, but the panels, depending on the satellite, have to be pretty long because you have to provide all the power that you need for whatever payload equipment is on your satellite. So, yeah, so depending on the satellite, if you like put the satellite on top of an airplane, the wings could potentially be as long, or the solar rays could potentially be as long as the wings on the plane. Okay, so I know you guys talked about a lot of the different parts of a satellite. So there's an antenna to talk to the Earth, right? There's no one on these things. They're completely unmanned, right? So they have to be able to take care of themselves. There's always some type of transmitting device for whatever type of payload you have. This one has this reflector on the side. The idea here is that the signal comes in, bounces off the reflector, and goes into the equipment on the side. And then the reflector basically lets it shape the pattern that comes onto the Earth. Okay, so as far as power goes, again, I'll say Mr. Carey is the sun. In order for the spacecraft to be getting power, panels have to be pointed at the sun. So as the day goes on, if the satellite stayed pointed in one direction, as it came over here, its antenna wouldn't be pointed at the Earth anymore, right? So it has to be able to turn itself to stay pointed at the Earth as it follows the Earth around. And so the way it does that, I'm sure you guys have seen a lot of space movies, like, anyone seen The Martian? Basically, if you're in space and you want to go that way, say you're holding a wrench, you could throw the wrench this way and you would start drifting the other direction, right? So the satellite control works a lot like that. There's these big wheels that are inside the satellite. And so if it needs to turn this direction as it goes around the Earth, it'll spin a wheel the opposite direction. So the wheel spinning this way will cause the satellite to turn this way. And so that's how it's able to turn and stay pointed at the Earth.
I know it's been 3 years, but anybody remember Newton's law, which one that is, what he's talking about? Ooh, zanger.
There you go.
For every action, there's an opposite and equal reaction. Okay, that when he talked about throwing the wrench and then going the other way, remember that balloon experiment we did? Okay, that's what he's talking about.
Yeah, so it uses that, and that's not also just for turning, but the sun is pushing on the satellite, so it feels the sun radiating on the satellite, and that causes it to want to tip over. And so it also has wheels to keep it from tipping over. There's also thrusters that it can use when the wheels can't handle all of the torques. So yeah, and so then the other thing that has to happen is that if the wings are always pointed this way, then as soon as you got here, now my panels aren't looking at the sun anymore. So the spacecraft has to turn the panels as it's going around the Earth to make sure it still has power. Okay?
So do the thrusters have to use fuel?
Yes.
So you have to have so much fuel loaded on there also.
Yeah. What happens basically is that the wheels will spin up and spin up and spin up and get to the point where they can't spin up anymore. And so what you have to do is use the thrusters to try to spin the spacecraft the opposite direction so that you can spin the wheels back down and use them again. A lot of people asked about how they get up in space. So we talked about the rocket. The rocket will put it in sort of a lower orbit, but to get all the way out to the geo orbit, we have to fire thrusters. Basically be circling the Earth in like an egg-shaped orbit, and you have to fire thrusters as you're going around to keep making the orbit bigger and bigger until you get out to where you need to be. And that actually there's giant fuel tanks on the satellite, and you actually have to use almost all of that fuel just to get out there. And then once you're out there, the rest of the fuel that you have is just used for keeping you in place.
Is that all programmed in, or do you have to do it from
No.
a station?
Yeah. So that's actually a big part of what my job is. We design the software that goes on the satellite. And the satellite has to take care of itself, and there's requirements that it has to be okay if you just ignore it for 2 days, right? So that means that it has to do everything to keep itself pointed, to keep the wings pointed, and then as far as thruster firing, those are the things the ground plans out and says, I'm kind of drifting away from my slot where I'm supposed to be, so I'm going to fire thrusters to move back. So they plan all that from the ground and send it up to the satellite.
Is there a margin for error for satellites, like how far in and out they can be and still do what they're supposed to do?
Yeah. Basically the way it works is that when you want to launch a geo satellite, you have to sign up with this international, it's like an international communications, I forget the name of it, but they basically decide who's in each orbit slot all the way around the Earth. And each box is only so big. So, yeah, if you start drifting out to the edge of your box, they keep track of where everything is. And, you have to fire thrusters to make sure you stay in your little box. And all these satellites, there's hundreds of them, thousands of them, So they're all going around together. Yeah, and some of our customers are better at it than others. There's a customer we have in Luxembourg where they actually have about a dozen satellites. They're sort of doing a figure eight, all in the same orbit slot. So they figured out how to keep them all moving relative to each other as they're all going around the Earth. And that's just so they can have different patterns on different parts of the Earth. Sorry, I'm talking with a mask on is hard. I see why you do the face shield thing. Okay, so let's see. Other questions you guys had. How much do they cost? Well, does anybody have a guess?
Around 2 million, I'm guessing.
More than that.
50 million.
The cheap satellite would be about 100 million. Yeah, and the more complicated ones can be 200, 300, 400 million. And that's just for this thing, right? You also have to pay somebody to launch it for you, and that's also probably another 100 million. So these companies are putting a lot of money into this.
Do you have to rent your quadrant?
No, you don't have to pay for your slot. But like I said, there's this committee you have to go to sign up for whatever slot you want. And then once you do that, you have a certain amount of time to get something in that box, or else you lose it. And then typically what a customer will do is, once they have the slot, they'll keep launching stuff, put a new satellite in, get the old one out, and then they can, it's squatters' rights, right?
Yeah.
So they can hold on to their spot. Let's see. So a lot of people asked, what do you do with them? Or how many there are, first of all. So I actually had to Google this because I wasn't sure. There's about 3,000 satellites in service. And there's about that same amount that are old and out of service. And so people ask, what do you do with satellites when you're done with them? You can't bring them back to Earth. Like I said, they have these giant fuel tanks, and it takes almost all that fuel to get them all the way out 22,000 miles away. So what they do is when it's at the very end of the life of the satellite, they save a little bit of fuel, and they use that to push it out even further. And that way it's out of the way and won't interfere with any of the other satellites. So you basically just push it off into space. Yeah.
Isn't there like a lot of debris from launching rockets and stuff that's floating around in orbit that have been collisions with satellites have completely obliterated them? Is that a risk with modern satellites?
They have to plan, anytime you launch anything, they have to plan it very carefully, because like you said, there's all this debris that's floating around the Earth. So they actually track every piece of space junk over a certain size, and then when they plan their launches, they have to make sure that they're not going to crash through anything. And it gets harder and harder
Yeah.
as there's more stuff up there. Yeah.
What happens if you get all this money, right, and then you have the satellite out there, and then it hits another satellite?
Collisions don't happen. The reason they call space is that there's a lot of it, right? So even though there's thousands of satellites out there, these, like I said, these are things that are 22,000 miles away, and so each box sounds like it's pretty small, but is really thousands of miles. Okay, these things are traveling 2 or 3 miles a second to go around the Earth once a day, but they're all moving at the same speed, and they're all spaced out. What does happen though, and I showed a video of this, lots of videos the last time I was here, is that the launch doesn't always work. Sometimes the rocket blows up, and so the company has to also pay for insurance for their satellite, because if it doesn't make it up to orbit, then they kind of have to start all over. Yeah. It stinks for us too, because we work on these things, for several years. kind of get emotionally attached to them. So if they blow up, it's not very fun.
So how long does it take? I mean, you just said something about how long does it take to build a satellite? I know that was somebody asked that.
Yeah, good question. So that also depends on the satellite. A quick development would be like 1.5 years, 2 years from the time that they say, they pay for it, they say they want us to build it until it actually launches.
Wow.
1.5 years is pretty quick. Usually it's more like 2, sometimes 3.
How many people are working on building a satellite?
Well, just in my company, we have, I work for Boeing, or at least the satellite portion of Boeing, and we have, I'm not even sure, over 10,000 employees. Because we have the people that are actually putting them together out in Los Angeles, and then there's the people that, design it. We work on the software, there's people that design, there's millions of components on these things, and there's somebody responsible for all of them, so it's a lot of people. And then we're building, 5, 6, 7 of these at the same time, so it's a lot going on. And that's just our company. Yeah?
How long does it take to get launched and then like be in orbit and actually work?
Yeah, that's a good question too. So it depends. The more you pay for a launch, the better the launch you get. So there's actually launch companies that will put you all the way out, so that you're almost in your orbit, and that way you have most of your fuel. You don't have to have as much fuel because the rocket's doing all the work for you, but that's really expensive. Some of our newer satellites now are getting put into a lower orbit, and they're actually going to spend almost a year firing thrusters to get them out where they need to be. And it all just depends on, it's a trade, right? How much you want to pay, how much fuel do you want to have on your satellite, how quickly do you need to get them to orbit. So that's the stuff that the customer has to figure out. Yeah?
Do we have any way to like get all the space debris stuff that we put out in the orbit out of it?
They're actually working on that. I saw they're working on basically a garbage satellite, a garbage truck, right? And they had, it's in addition to these big panels, they also had like I don't know, fly paper. It's a little more complicated than that, but that's the idea. They just go around with this big piece of flight paper and pick up all this crap that's floating out of space. But yeah, it's definitely a problem, and it's something people are working on. Yeah?
Like, how much fuel do like the satellites have? Like,
Well, again, it depends, but the fuel tanks themselves are probably like the size of that door, maybe that high and big around, right? And then they'll have actually 3 or 4 of those. That's the biggest part of the weight of the satellite. I didn't mention, I know you guys have covered the periodic table. Most of our satellites, well, there's 2 kinds really, but a lot of our satellites now are using electric propulsion, which is, look, imagine a mouse floating out in space. If the mouse farted in this direction, then the mouse would drift in this direction. Yeah, that's basically what we're doing, right? It's a little more complicated than that, but we shoot out ions in one direction and just cause a tiny little drift in the other direction. And typically what they use for that is xenon. If you remember your periodic table. The far right, do you have? Okay, the far right column is your inert gases. The inert gases are good because they don't want to react with anything else. And xenon is the heaviest of those that is not radioactive. So they use that for a lot of our satellites. Again, they basically electrify it and shoot it in one direction to cause a torque in the other direction. Yeah?
Generally, how much does a satellite weigh?
That varies a lot too. basically, it could be about the size of a car, the weight of a car, maybe a ton or two. And again, it's just, it depends on how much fuel they have, that's the main driver.
Are the solar panels as fragile as what they look like they are?
Yeah. Yeah, one trick of designing these things is that, when they're in the rocket, it's a rough environment, right? You're fighting all these, you're trying to get out of the Earth's gravity, shaking. Anyone's watched a movie about astronauts launching in space, right? They're getting sucked back into their seat. But once you get up into space, then these things are made out of aluminum, right? They're pretty lightweight. You don't want to have any excess weight because the more you weigh, the harder it is for you to launch you. So yeah, it's sort of a design challenge to make them as light as possible, but also be able to survive the launch without getting crushed. Yeah?
How long does a satellite last?
That's a good question. Usually it's around 15 years. Obviously, once the customer gets it up there, they're going to try to use it as long as they can. So they try to save their fuel. But sometimes they just fall apart. The space environment is pretty rough. There's space junk, there's solar flares, radiation, and so everything just degrades slowly over time. But typically the contract life, like we're required to design these things to last 15 years. Sometimes they'll last 20 or 25 before they actually have to deorbit them. One thing I wanted to mention too, so the satellite's up here, right? Well, how does it know whether it's pointing this way or this way or this way? Right, so you guys, I think you talked about star trackers.
Was that on that?
Yeah. So that's what most of our satellites use these days. You think about, you look up at the sky, it looks like the sun's going across the earth, going across the sky. At night you see the stars, it looks like they're going across the sky. But that's just because the earth is turning. Once you get up in space, Mr. Carey's the sun, he's always right there, right? And the earth is turning, and it's also slowly going around the earth. So the satellite can use the sun as one way of knowing where it's pointed. And the stars also, say the Big Dipper is over here, it's always there, right? So the way these star trackers work, they're basically cameras, and they take pictures of the sky over and over and over again, and they look to see what stars it can see. And it doesn't care about constellations or the names of the stars, but it looks to see how bright they are, how far apart they are, and based on that, it knows all the stars. It says, well, okay, I am pointed, because I can see these stars, and this satellite, the star tracker is right here, looking this way, so it'd say, well, I'm looking right here, and the panels can find the sun, and so the one piece that it doesn't know is where's the earth, right? So that's something that the ground, well, there's two ways to do it. You can have the ground tell it, because the ground knows where the earth is. It's constantly going around the sun, right? Or the newer satellites these days have GPS receivers, just like your phone. And they can use those to say, okay, the earth is here. And so they can continually track the earth. But yeah, the main, once they do that, then they can use the star trackers, say they're tracking stars in the Big Dipper. They can see if the stars start moving across the field of view of the star tracker. It says, oh, I'm starting to move this way, I need to correct myself. Okay? Anything I didn't cover? Anybody else have questions?
You said the solar panels were folded up like an accordion
Yeah.
when they're in there. Okay, so when it's released, are they like spring loaded or is it programmed in?
We do
or-
it both ways. Yeah, so there's some satellites where panels are, folded up for launch, and then we carefully step them out over time. And it's very controlled, it's very slow, it takes like almost an hour when you have, 5 or 6 panels that are stacked up to get them all the way deployed. That's sort of a less chaotic way to do it. Our older satellites, and actually some of our newer ones, it's spring loaded, like you said. So they have these bolts that are holding the panels down so that they don't spring out. And the reason they do this spring loaded way, at least for the newer satellites, is that they need to usually the ground is in control and says, okay, now it's time to deploy our wings, let's slowly step them out. But for some satellites, you don't have time. You need them to go out as quickly as possible. And so they basically have these bolts that are holding the wings down, the panels down, and they fire, there's basically a small explosion that fires a knife into the bolt, which causes it to break, and then the panels just pop out. It's very violent. We don't like doing it that way, but sometimes we don't have a choice. So, yeah.
How often do you launch satellites into space?
I mentioned that there's like 3,000 satellites in orbit right now. Most of those have happened in the last few years because they're doing so much these days with all these really small microsats that are in a lower Earth orbit. Our company typically doesn't have more than 2 or 3 launches a year. Last year, I don't think we actually launched anything, which was good timing because of the pandemic. Couldn't really all get together anyway. So, but yeah, usually our company will launch 1 or 2, maybe 3 a year.
How many satellites are you working on now?
Too many. The main program that I'm working on is for a company called Viasat. It's going to be over North America, and I've been working on it for about 3 years. It's a really long program. Like I said, most of them are shorter than that. But we've had a lot of contracts lately, and we don't have enough people. So right now I'm working on 5. Yeah, it's a mess. But we do some cool stuff, so it's nice to be involved in a little bit of everything.
So if it takes so long, and I can imagine all these people working on this, when it's time to launch it,
Yeah.
do you guys get to actually watch and see what's going on?
Yeah.
Or just the people responsible for that part?
No, everybody's watching. We're not, we don't have any control. Basically what happens is we have a team that is getting data from the satellite on the launch pad. And we have a say up until about 30 seconds before launch, and we can do a no go, and stop the launch if something goes wrong. Something's wrong on our satellite. But then once we get to that last 30 seconds, it's hands off until it launches. All the stages of the rocket break off, and then once we finally get separated from the rocket and we come in view of a ground station on the Earth, then we take over again. So we'll have a team in our control center waiting to acquire the satellite, and then that's when we start making sure everything's working, and we start getting it into its right orbit. Like I said, that can be anywhere from weeks to a year, depending on the type of satellite. And we test everything, make sure it's working, and then we hand it off to the customer and they start making money. Yeah.
Do the cameras ever catch like exploding stars? And if they do, does anyone care?
We don't know. They don't analyze the data from the trackers. We have seen some interesting stuff before. Sometimes like, for example, when you deploy the wings, or I keep calling them wings, when we deploy the panels, what you'll see is that it kicks up a lot of dust. And so the star trackers get confused because there's all this sparkling stuff being illuminated by the sun. And sometimes it will have a hard time figuring out what it's looking at just because of all this dust that gets kicked up when you deploy the panels. But yeah, they don't, the star trackers on the satellites are used just for looking at stars to figure out where it's pointing. But a lot of satellites do have observational type equipment for, like the Hubble telescope, for actually doing scientific experiments and monitoring stuff and that kind of thing. Yeah.
So you said you were in the programming team, right?
Yeah, we work on
Yeah.
that software.
So, how many people are in your team?
So my group is about 10 people that works, but we just do a particular part of the software. Our part of the software is for it's called autonomy, so basically making sure the satellite can take care of itself. So that includes making sure everything stays warm. That's something I didn't mention, but as the slide's going around, it gets over here, and certain times a year, the Earth is completely blocking the sun, right? And so it goes from being really, really, really hot to really, really cold. And so we have to be able to, there's heaters on board, and it has to be able to control those to keep all the different parts of the satellite warm. And that's true even as it's rotating, right? So this time of day, this part of the satellite's hot, this side's cold, and then 12 hours later, it's the opposite, right? So you have to continually watch that and make sure all your equipment is staying at the right temperature. And then another big part of the software that we work on, my group, is making sure that if anything goes wrong, the satellite stays safe. And that's the most complicated part of what I work on, because we have to figure out what are all the ways that this thing can break, and what happens if it does break, and what do we do, right? So you kind of have to expect the worst and try to plan for it.
That was my question. Are there certain things you can fix if something goes wrong on the satellite, or?
Not with humans, right? So the way they design these things is that there's a backup for everything. And sometimes there's 2 or 3 backups depending on how important the piece of equipment is. So yeah, so that's what our software will do. Take the star trackers again, for example. Our software has to talk to the star tracker, and get information from it. And if it stops getting information, then there's a lot of things it can try, right? It can try to power cycle it, or it can switch to the backup and try to get data from the backup. But then there's other cases, like say the star tracker just gets confused, or it's broken, and it's giving you garbage data, right? So you're supposed to be looking at these stars, but instead it says, oh, I'm looking at these over here, right? And so you have to be able to figure that out and stop using it, because otherwise your satellite's going to drift off the Earth. So it gets complicated. Yeah?
Is there like an actual job where you just monitor satellites all day?
Yes.
Not in a physical business, but I didn't know.
Yeah, actually, and most of the people that do that don't really know a whole lot about the satellites. They basically just know the very basic things about, if this happens, do this, if this happens, do this. And if something goes wrong, call somebody, right? So they don't want to pay a lot for these people that are sitting there every day, 24 hours a day, just watching these things. Because most of the time, they take care of themselves. But yeah, when something goes wrong, then you need to get people involved that know how to handle it. Yeah?
So, what do the probes do that you send up on a satellite? Like, extended probes?
Yeah, so, like NASA, for example, does all kinds of stuff. They send, out of this, past this georbit, and they send things to go, look at other planets and moons, and, yeah, there's no limit to the type of, equipment that they can put on these things. It's really up to the customer. And I actually have no involvement in that at all. For all these programs that I'm working on, I honestly couldn't tell you, what they're gonna be used for. All I know is that it's gonna be here, it has to, we get requirements on exactly what the satellite has to do, and then we just design to meet those requirements. Yeah,
What do most people want a satellite for?
for the customers,
Mm-hmm.
generally communications, and it can be any type of communications, whether it's, GPS or internet or phone, yeah, there's all kinds of things that you use it for. Let's see. What was one other thing I was gonna talk about with the satellites was, so not, everything doesn't always, actually, one thing just for scale, so, if the Earth was actually this size, right, the moon is about a quarter of this size, so it's about the size of a softball maybe, and, it would be in an orbit that's about, 45 feet away, so it'd be outside of this classroom, right? So the moon is a softball just outside the classroom going around the Earth, and its orbit is 28 days, right? So the month is roughly based on the lunar orbit. And then the sun is, it'd be about the size of St. Francis. It's really big, right? So, and it would be about 3 miles from here, so maybe out at like Sam's Club. If you can imagine something that big out at Sam's Club, that bright. That's how big the sun is relative to an Earth this size. Okay. Yeah. So So the other thing I was going to talk about is, when the satellite's working perfectly, everything's great. But a lot of times things will go wrong. And so we get calls from our customers sometimes. We actually have a whole group in our company that's dedicated just to supporting the customers, so that when things go wrong, they don't call us, they call these people that sort of funnel the stuff to us, so that we're not getting direct calls from Germany or wherever. But yeah, so sometimes things will happen. A unit could fail. We have had star trackers fail, and then it'll automatically switch to the backup. And then the customer will want to check out the old unit to make sure, is it really useless? Because what happens if our backup star tracker fails? Then we're in trouble, right? So those are the kind of things that we have to get involved in to see what happened and whether it's really a failure or if it just was a glitch and it's now working fine.
Have the size of satellites changed since they were first starting to be made?
Oh yeah. So and they're all different these days too. So the first satellites were built in like the 1950s. And actually, does anybody know the name of the first satellite that was put into orbit? Anybody that watches Friends?
Oh.
Ross's Halloween costume?
Sputnik?
Oh,
There you go.
yeah.
Yes. Sputnik. So that was the first satellite that was ever launched. It was about the size of a basketball. And it was basically just for scientific purposes. Basically, they just want to get something into orbit to say, hey, we did it first.
Something's in order.
Right? And so then the United States, about a year later, launched, I think it was called Explorer 1.